Oh, there it is. Yeah, I found it. Okay, it's C6, 0.05, 200 volts. As you can see, it goes from chassis ground, metal cabinet, okay, which is this right here, soldered right to the cabinet here, and then it goes to that lug on the 12SK7, pin 1, 2, 3, pin 1, 3, okay. But anyways, and that is the common ground point here, okay. And so I've got to replace that guy. So that's next, C6. 0.05 at 200 volts. I think that'll be the first capacitor I actually replace. Now, because there's so many lugs, there's so many wires soldered to this point, that it's going to be a bear to remove all these wires with a regular solder sucker. It would just take forever. I could hurt the terminal, unnecessarily heat up the surrounding components, like this is mica capacitor here. And I don't want to go through all that. And another easier way to do is just to cut off the lead line right here. Cut it off somewhere around here. And then you can put all different ways of hooking it up. What I usually do is just make a little loop, half loop, a pair of needle nose, just turn it in with the new capacitor, and then crimp them and then solder them. It's just as good. Okay, and then that way you don't have to worry about trying to remove all these wires here. So let's go ahead and do that. I think my soldering iron should be warm enough now. My sponge is dry though, so I'll be right back. Okay, I'll look through my list of parts here. And I need a 0.05 at greater or equal to 200 volts. 0.047, that's it there. Close enough. Okay, 0.047, 630 volts. This one was rated at, I need my flashlight, sorry, at 200 volts. And this one's 0.047, 5% at 630 volts. Maybe you can see it better that way, less clear. Okay, so take that out of the package. Now, like I said before, if this was my radio and I was going to keep it and I wanted it authentic, I would go through all the trouble of stuffing the capacitors. But my relative that's going to get this radio, he is never in a zillion years going to look under the chassis. So what I'm going to do is I'm just going to put a modern equivalent in there, and it'll look like that instead of this. When I restuff them, you melt out the wax, like I said before. You put something around it like paper to build up the diameter so it fits in tight. Put hot glue in there, and you're done. It looks just like this. It's great. Another reason that I'm not going to do that with this is a Majestic. None of these capacitors say Majestic. As a matter of fact, most of these are solar over here, some oddball name over here, some no-name electrolytic here, and this one's kind of nice, though it says solar. But I'll probably save these for another project. But for this radio, this is good. So, let's clip out that lead. Alright. And kind of like entangled with each other here. Here we go. Get a little bit more room. Now I noticed that this wire here is pretty close to this terminal here, and depending on how I arrange this, I may want to go ahead and put some heat shrink over here. maybe this stuff here, because what's going to happen is this capacitor is going to need to go this way and down there, and it could pull in. See, look how close it is to that other terminal. So I might put some heat shrink compound over there. See how it goes. Another thing I like doing too is I like bending the leads so the value is visible. A lot of times you work on this radio, you got to twist the capacitors all around just to see what they are. The way I like to install them, if they are going to be visible like this, well, even if they stuff them, I'll make sure that the value in capacitance and voltage is facing up, so it's real easy to read it. Okay. Just a simple thing to do, keep in mind to do. Okay. Another thing I like doing too is I like kind of like pretend this is the bottom, this is the top, and if you were reading English, you would read this way, left to right. So I would install the capacitor, all of them, as much as I can, so they all line up. So you're not reading one this way, then you're turning your head and reading this one this way, and then you're turning your head and reading this way. I do the same thing with the resistors too, if I'm replacing a whole bunch of resistors. Like this one here, you can see you start reading it from this way. They did the same thing with this way, left to right. It looks like from sideways, this one is top to bottom. And if they consistently do that, well, it looks like they did that here. I think I gotta move the camera over so you can see it. This brown, red resistor, it's left to right. Well, here's an instance where they didn't do it over here. Let me move the camera. Okay. So you can see this resistor, red, orange, okay, which is 22K, is reading from top to bottom, but then this one they got going this way. So if I was to replace all, I would like to try to keep them uniform. Don't have to, but I just think it makes it a little bit more neater and easier to read, and for the next guy, whoever works in this. Okay. So put a little. This is kind of. I'll straighten out the wire a little bit more, I think, here. Got a lot of kinks in it and stuff. Alright, about like that. Yeah, that's a little straighter. Okay. These, I got recently, and I found them invaluable. They're great for, I used to use bigger needle nose. I don't have them right here, but the standard bigger needle nose. Or I'd use this. No, these are great for handling lugs like this, straightening them out and everything because they're flat. And it's great for if you have a can capacitor and it's got twist lock tabs, these are great for that, for twisting them out so you can pull the can out and restuff it, the can electrolytics. But for bending wires, this thing's great. It bends them nice like that. So that's what I've been using. Anyways, put a loop in here. I said I was going to try to make the writing go this way. So this end, let's see, that'd be pretty good there. I think I'll put a bend right about there. Yeah, that looks pretty good. Matter of fact, if I do this, that. There. Okay, and if I make it about like this, yeah. Also, okay, so I'll bend the wire about like here. Put that off. Loop a little bit. This loop. That's pretty good there. Now I did say I was going to put a little bit of heat shrink there, didn't I? The way I was starting to wire it in there, I could tell that I could get away without it, but since I said I was going to do it, I think I will. Yeah, I'm probably going to need about that much. Now I'm going to want to keep the heat shrink, obviously, as far away from where it's going to get hot, because this could start shrinking and I won't be able to slide it over. So we'll see how this works out. Should be pretty good.